Some people question whether it makes sense to work in 3D for specific types of designs, like progressive dies. I'll say this. In 2D, it's next to impossible to have the type of automation that you can create in 3D when you have everything in a spatial environment. For example, here we're running our fixing wizard. What we're actually going to do is insert 4 screws as well as some dowel pins all at the same time. We're going to locate them all at the same time, and we're going to process them through every single plate automatically, again, all at the same time. And here you're choosing the diameters you want, you're choosing the lengths you want, you're getting exactly what you want, but you're doing it in a very, very fast and efficient way. So for example, if we look, these are all of the items that are going to be added. Again, there's their positions, we validate, and in a few seconds, we're done. Let's take another example. Here, we're going to add a dowel pin. Let's maybe say we're looking for a 5mm dowel pin with a length of about 20mm. We'll validate. We'll position it on this face here, off this edge for 5mm down, and maybe between that edge and that edge centered. And like that, we have our dowel pin. We'll change its color real quick too, just so you can see it. There's our pin. And you can see it processed itself even out of that complex shape. Very cool. Let's maybe change the depth and shift it a little bit. And like that, you can see the pin shifts. Awesome. From here, let's take a look at adding a spring. Springs are important in dies. We're going to fill in some basic information. And like that, now we just need to position our component. We're going to position it off that face using that edge, 40mm in, off this edge, how about 80mm in? And now we're going to turn on another plate to get the proper reference face for the other side of the spring. So now you can see the component is positioned, and like that we can choose from our library codes that respect our constraints only, fill out specific information that we're looking for, the resulting force, length used, what have you. We'll choose a bigger spring. You can see it dynamically updates there in the background, and again you can continue getting your resulting information. Like that, our component's in, and moreover, it's processed the component, which means it's put in the correct drillings. From here, we'll do a custom pattern of this. We're going to do it on coordinate systems. That'll be our destination, and we're going to use a group that we defined ahead of time. Like that, we now have 4 springs. Cool. Let's maybe add another component. How about if we add a shoulder bolt? Let's start by setting the diameter we're looking for, and then choosing our destination face. We'll choose the bottom of that spring pocket there. And then we're going to turn on that top plate again. And we're going to choose the reference face up there to help set the length that we're looking for. And you can already see TopSolid Progress has chosen the correct component, and like that, it's even processed it correctly now. Very, very cool.